Hello everyone, welcome to homework 15. We're going to be going over rational exponents. So in this one, if we are given some number to a power that is a fraction, what that really represents is a radical. And so it says right here, notice that the denominator of the rational exponent corresponds to the index of the radical. So whatever that bottom number is, that's what becomes your index. What I usually like to do is, especially whenever they write the fraction like this, if it's wrote like something like 1/2, not like that, but if it's like kind of like this right here in that form, what I kind of do is I circle that top number, that numerator stays. So that's the same as a to the first. And then that index, or that bottom denominator, is what becomes the index. So example 1, use rational notation to rewrite the following. Simplify if possible. So 36 to the 1/2, that 1 is going to stay as an exponent, and then that 2 will come around and become the index. So this is the same as the square root of 36. Now, of course, we don't really need that 2 with that square root. If you just put radical 36, that's known to be square root, right? And this is technically to the first power, but we don't need that either. And then the square root of 36 is 6. Okay, with these, you just use the principal square root, so we don't need plus or minus 6. It's just 6. Same thing on B. That 1 is going to stay as an exponent, and that 3 needs to come around as the index. So this is the cubic root of negative 64. Because our index is odd, it's okay to have a negative under that radical. So the cubic root of negative 64 is negative 4. And you can put that in your calculator if you need to. Now, B and C are very close. Let me go ahead and erase all of this. B and C are very close. What's the difference that you can see right off the bat? Hopefully you're thinking parentheses. Remember, when they have parentheses, that includes that negative with that base. When they don't have parentheses, that exponent is only going to 9. So we'll have 9 to the first, and that 2 will come around, and that negative is outside. So this becomes negative square root of 9 to the first. But again, we don't need that square. We don't need that first power. So negative square root 9 is going to be negative 3. Square root of 9 is 3, and then that negative gets tacked on. So make sure you know the difference between these two with that negative. One's in parentheses and one is not. And then x to the 1/4, that 1 will stay as an exponent. That 4 comes around. So we've got the 4th root of x to the first, but that's the same as x, and I can't simplify that at all. So now we're going to do the same thing on example 2, but we're going to go backwards. We're going to start here and go to here. So example 2 says convert the radical expression to equivalent expressions involving radical exponents. So this is the same as 10 to the first. That 1 is going to be the numerator, and then this index is the denominator of your exponent. So this becomes 10 to the 1/4. Okay, same thing here on on B. This is the same as x to the first power. And there's a known 2 to be right there in that radical. So this becomes x to the 1/2. This right here, what we did on example 2, is mostly what you're going to need for calculus. When you get into taking the derivatives and using the power rule, you need your radicals to be in radical exponent to be able to use that power rule and take the derivative. So it's going to be really important that you know how to go from here to here. And then maybe you'll do these as well. You'll convert it back into exponent, into your radical form, but it's really important that you know this right here. Now, this is the exact same thing, but now it says if m and n are positive integers greater than 1. So now we have things like 2/3 power to the 3/5 power. So it's not 1 over a number. And that's literally the only difference. This is always 1 over a number. And now both m and n can be any number. And these work when you change it from exponential to radical. You've got two different things that are equivalent. One of them has, and it's all about that exponent. One has that exponent under the radical. And so if you're using order of operations here, you are finding out that exponent first, and then you're finding the nth root of that number. Versus this one here has that exponent on the outside. So with this, in this form here, you're going to be taking the nth root, and then whatever this number is, then you're taking it to that exponent. Okay, so for example, right here, if you go in this first one here, that 2 stays with the 8, and the 3 comes around. So this becomes the cubic root of 8 squared. So what they do first is 8 squared is 64, and then the cubic root of 64 is 4. The other way to do it is that 2 still stays as an exponent, but it goes outside the radical. And then that 3 comes around and it's still in the index. So now we have the cubic root of 8 all to the second power. So they take this one first. The cubic root of 8 is 2, and 2 squared is 4. So notice they got the same answer using both of those definitions. It does say here in your helpful hint that most of the time it's going to be easier to have that exponent on the outside. And it's really the same thing no matter what. But notice here we got 64 versus 2. When you take that exponent first, it just creates you to have bigger numbers. And so that's why they usually like this form here. Just because you're always going to be dealing with smaller numbers since you're taking the nth root of a number. So I am going to use this definition here. Okay, so example 3. Use rational notation to write the following, and again, simplify if possible. So 4 to the 3/2, that 3 stays with the 4, that 2 goes around. So I've got square root of 4, all squared. Nope, all cubed, sorry. So the square root of 4 is 2, and 2 cubed is 8. Same thing on B. Now, does that negative go under the radical on B? Hopefully you said no. Because it's not in parentheses, that negative is not included. So that exponent will be 16 cubed, and then that 4 will go around. So we'll have negative 4th root of 16. And then that is all to the 3rd power. So the 4th root of 16 is 2. And that's another one. If you don't know, you can put that in your calculator. 2 cubed is 8. And so that negative comes down. So that's negative 8. Now, and see that negative is included. So we'll have negative 27 to the second power, and then that cubed comes around. So we've got the cubic root of negative 27, and this is all going to be squared. So the cubic root of negative 27 is negative 3. It is really important that you keep your parentheses in this one, because negative 3 in parentheses is 9. If you do not have those parentheses, it will come out negative 9. So you've got to make sure to keep those. And then lastly, it's going to be 3 cubed, and then that 5 can come around. So we've got the fifth root of x cubed. And since we're not solving anything and simplifying, I'm going to put that cubed under the radical. So on this one, I used this definition. And then we need to work backwards, because again, you're going to be asked to find the derivative of this. And so to be able to find the derivative, you first need to put it in exponent notation. So w to the 5th, and then that 8 will come around, become the denominator. So w to the 5/8 power. X to the 7th, and then that 4 comes around and becomes the denominator. So x to the 7/4 power. Okay, these two here, again, that's what you need to be comfortable with doing. And then we have the definition of a to the negative m over nth power. We treat this like normal. When it's negative in the top, move it to the bottom, and then it becomes positive. So 16 to the negative 3/4, to turn that exponent positive, we'll put that 1 over 16 to the 3/4. And now we can work. So it's going to be 16 cubed. That 4 is going to come around. So 1 over the 4th root of 16 cubed. The 4th root of 16 is 2. And 2 cubed is 8. So my answer here is 1/8. And so notice, even though this exponent is negative, my answer is still positive. Okay, that negative in the exponent doesn't mean anything about if my answer is positive or negative. Same thing on B. We need to make that positive first. So this becomes 1 over 4 to the 5/2. When you move it from the from the numerator to denominator, it changes that exponent from negative to positive. So now let's rewrite this. This will be 4 to the 5th, and that 2 is going to come around. So I've got the square root of 4 all to the 5th power. The square root of 4 is 2. And 2 to the 5th is 32. So it becomes 1 over 32. Now this is mostly, again, example 4. And I will even go ahead and highlight this for you. Example, or maybe I won't. My highlighter's not working. That's sad. Okay. Well, instead of highlighting it then, I will box it. Example 4 and example 2 is mostly how you are going to be using this in your calculus class. But I went ahead and decided to add in this as well, because this is another nice thing about rational exponents. So we've already gone over the product and quotient rule. And the biggest thing with these is, notice you have an index of n, you have an index of n. When your indexes are the same, you can multiply. So if we have the cubic root of 8 over the cubic root of 2, we can make this the cubic root of 4 because this index is the same as this index. What happens though is what happens if I have the cubic root of 8 times the square root of 2. Well, now because these indexes aren't the same, up until this point, we've just been saying, whoa, Bessie, we can't do that. Well, with rational exponents, we can do that. So what we're going to do is we're going to take these, convert them into their rational exponent forms, and then those rules we learned last week of exponent rules, those apply. So example 6 says use rational exponents to write as a single radical expression. So the square root of x becomes x to the 1/2 power, right? There's a 2 here, there's a 1 here, times the cubic root of x becomes x to the 1/3 power. We've got a 1 right there. So now I can use this rule here. So in your calculator, if you just do 1 divided by 2 plus 1 divided by 3, you will get, I think, 8.33 repeating. Okay, 8.3 repeating. These decimals don't help me at all. So then hit your math and then hit that little fraction key. And that turns into 5/6. And that does help me. So I get x to the 5/6 power. And because I need to write this as a single radical expression, now convert it back. So that 5 will stay, that 6 goes around. So my final answer is the 6th root of x to the 5th. So that's kind of cool. Since I can't multiply them in that form, I can convert it into a form where I can. So same thing here on B. The 5th root of y cubed becomes y to the 3/5 times y to the 1/4, right? There's a 1 here, times y to the 3/10. So add those all together. Okay, and you're going to get 1.15. That doesn't help me. So do your fraction button, math, fraction. And that becomes y to the 23/20. So now convert that back. That stays. The 20 goes around. So this is the 20th root of y to the 23rd power. Now, I'm not sure if it will take this, and I don't think you have any problems that are like this. Whenever you have a bigger number on the outside, that means you can't simplify it at all. But when my number on the outside is smaller than the inside, you can technically simplify it. So my math lab would maybe take this, and I don't think you have any in your answers like this, but you might have to simplify if you do. So 20 goes into 23 one time, and so 1y comes out, and then that leaves you with a remainder of 3. So y cubed. Okay, this is probably more proper because it is fully simplified, but they're both the same. Okay, so again, 20 went into 23 one time, so 1y came out. And then that leaves you with 3 y's as a remainder, and it just stays to the 20th root. Okay, same thing here with C. So convert those. That becomes z to the 3/4 over z to the 2/5. So now that I am dividing, I am using this rule here. And we subtract those exponents. So 3/4 minus 2/5 gives me 0.35. So fraction that, math, fraction, and that gives me 7/20. So we got z to the 7/20. And then we need to write that as a single radical expression. And so that will become the 20th root of z to the 7th. And because this number is bigger than this number here, we can't simplify that anymore. Okay, and then lastly, on D, it's already in radical exponents, but I do need to get this one positive here. So this becomes t to the 4/9 times 1/t to the positive 2/9. When you multiply straight across, this is the same as being over 1. So multiply straight across. And we get t to the 4/9 over t to the 2/9. And when I subtract, we get t to the 2/9. And now put that in radical notation, which is the 9th root of t squared. So not only are you going to use this in calculus to write it from radical notation to exponential notation, so you can take the derivative. You can also combine radicals if they don't have the same index. So that's kind of another little cool thing you can do with them. As always, if you guys have any questions, please let me know. I'll be happy to help you. Until next time, we've got one more lesson left, so you are almost done. Bye, guys.